In episode 64 of Mobycast, John shares his thoughts on Gluecon 2019, and then dives into one of his favorite sessions, which focused on AWS's Aurora Serverless. Welcome to Mobycast, a weekly conversation about cloud-native development, AWS, and building distributed systems. Let's jump right in.
Welcome, Chris and Rich. It's another episode of Mobycast.
Hey guys, good to be back.
Right on. So, Rich, what have you been up to this past week?
Closing deals.
That's what I like to hear. Can you give me a few while you're at it?
If I come across some that I think you should have, I'm definitely passing them your way. That's for sure.
Right on.
Yeah, it's been a good week. We've been working really hard on outbound sales. We're doing LinkedIn outreach. We're doing physical mailer outreach, and we've been doing it for a little over a year and a half, and it's starting to really starting to pay back all the investment. So it's a nice feeling. Although now now we have the other problem where, we have to fulfill all this work, and do we have the resources and the team and the time to do it? But it's a better problem to have than no work, I guess.
Yeah. Well, I plugged your company Secret Stash at the conference I was at this past week. If people want really good WordPress development, you are the one to go to for sure. How about you, Chris? What have you been up to?
It's been a pretty normal week.
I like normal.
Yeah, getting ready for a trip coming up here to San Diego. Although looking at the weather, it's like Seattle weather is a bit warmer than it is in San Diego, which kind of go figure. But I have been listening to a really cool podcast recently that I've been enjoying quite a bit. It's called To Live and Die in LA, and it's a crazy story. It's one of these true crime podcast where a Rolling Stone reporter gets introduced early on to this missing persons case within like the first week of this woman going missing, and then just researches it and goes deep into it with a private investigator. And it's a crazy story. It's like you can't write. It's like the truth is stranger than fiction. And,
very cool.
I've been enjoying it a lot. Yeah.
And as for me, I guess what I've been up to lately is going to be the topic of the rest of the show. So I went to Gluecon this week, which is a really fun conference down in kind of in the northwest area, northwest of Denver, just between Denver and Boulder. And I've been going for about 4 years, and it's run by Eric Norlin, who I consider a friend. And it usually just has lots of cool, innovative talks around open source, around cloud, around APIs, around, for a while when blockchain was hot, it had some neat talks about how blockchain worked and what people were trying to do with it. And also, they tend to sprinkle in a few out there talks. This year's out there talk was about how to program for quantum computers, which I was really excited to learn about, and actually super surprised. I thought it was going to be like, oh yeah, this, here's how the scientists do it. But it was more like, here's a place where you can go sign up for your own account. We have tools that help you restate your problem that you're trying to solve in a way that the quantum computer can understand, and everyone gets a free minute. And I was like, what? This is cloud computing now? You can get to quantum computers in the cloud today? And they're like, yeah, we're just trying to get people to realize that this is something they can use. And so, wow, here we go, quantum computing. I did want to. So, Chris, when you talked about DockerCon, you were sort of disappointed. And I think it was a Docker specific thing that, there's not a lot of innovation coming out of Docker, the company now. And it was really an enterprise-y feeling conference, like use Docker's enterprise tools and here's how Docker works kind of talks for the most part, right?
Yeah, I mean, it's evolved over the years to become, just kind of a feeling of less excitement, kind of more enterprise, more corporate, just again, as they transition to go from kind of a new startup with lots of innovation to now like, hey, we got to make money. What's the business model and focus on customers and the financials. And being that it is DockerCon and it's the official conference of Docker, right? It's run by Docker itself. So they set the agenda, they set the talks, and just the overall personality of the conference. So
Yep. And at Gluecon, I'm used to sort of general talks that aren't really commercial, and any, maybe a couple of commercial talks by some of the top sponsors, but everybody was sort of talking about how this year, a lot of the talks, maybe even as many as 70%, felt a little bit like, hey, here's this tool we're building. Here's how it works. Here's why you should use it, which is kind of disappointing, right? I would go into a lot of talks excited, ready to take notes, thinking this could be a great one for Mobycast. And then halfway through, I realized I'm getting kind of pitched and stopped taking notes. because
this feels like a trend now. Yeah. It's not just, I mean, this happened at DockerCon as well, and it's just like like it does. If it's super disappointing.
Yeah.
Where it basically feels like it's a marketing pitch.
Yeah.
And it's very specific to that particular company's product or service that they're selling, and
Yep.
it's just not very useful. And like I said, it's a pitch.
Right.
So really wish it kind of felt like that's been taboo in the past, like that just is not allowed.
Right.
And
How is this happening? Is it that people are clever and they're CFPs and it seems general? Because I did not know a lot of these were going to be pitches until I was in there and realizing I'm getting pitched. So yeah, it must be that like companies are kind of working around that.
The same thing with me. I mean, every time I've gone to a talk, it's like from the description, it looked interesting. It's like, oh wow, this is pretty cool. Like how do you debug like complicated like distributed systems, microservices architecture, distributed tracing? And it's like, oh, that sounds interesting. Let's go check that out. And it's like, what? This is someone's vaporware. And it's just, come on. It becomes like
there was a lot of that. And it's kind of fun, ironic is that what I'm about to talk about, which was one of my favorite talks, is unfortunately it is actually a product plug for AWS. But since it's AWS and since we talk about AWS a lot on this show, and since honestly the real innovation, the trustworthy innovation currently seems to be happening inside the public clouds and less outside the public clouds, I guess it makes sense to go ahead and give AWS a pass on this and go through this talk, and even though it's a pitch for an AWS product. So
there's a big difference here though, right?
Yeah.
The title of the talk was Aurora Serverless.
Yes.
It wasn't like how you too can run a relational database in a serverless way in the cloud, right? Like that.
Yeah, you're right.
And that's the problem, right? So it's totally okay as long as you tell me up front, like this is what it's about.
Right. Yep. That's a great point. So, and the talk was very good, and I really am interested, and I think a lot of our listeners are interested too, in AWS pulls off some of the really cool operational stuff they do with their cloud tooling. So this is Aurora Serverless, which is essentially database in the cloud that you don't have to scale up or scale down because you just send data to it and they take care of the rest. So you just SQL in the cloud basically. With a relational database, you give it a schema, and then you can query, and you don't worry about managing connections. You don't worry about tuning it. You don't worry about how big your instance is. You just worry about sending SQL to it. So how did they pull this off? I was kind of curious. And it's a thing that I've been excited about because, scaling up or down your database, vertical scaling of your database in AWS prior to Aurora Serverless has always been painful. It's always been like, okay, you got to find a window where you can migrate your data migrate to a bigger database. Nothing can be running during that window. And, it's not something you can do when you're getting hammered by a traffic spike and everybody's yelling, why can't this handle the load? Like that's not the time when you can scale up your database. Okay, so Chris, this is, I guess, going to be one of those ones where I'll have to do most of the talking, even though I'm not really the expert here on the show. So, but what I'll try to do is talk through some of the things that I learned, and then see if you have any sort of comments or ways to think about it that I'm not considering. Sound good?
Sure, sounds good.
Okay. So first, so the talk was by Anup Gupta. He's I think basically a product manager at AWS. So he's really product focused on how Aurora Serverless works. But he's quite technical, and it was, as all the product managers at AWS are. And so he was able to give a good sense of the architecture, the software architecture, and how it's all put together. He started by giving an overview of RDS. We've done that on the show before. It's a database in the cloud. Everybody kind of knows that, but it's provisioned. So, and RDS is, literally MySQL or literally Postgres or literally SQL Server or Oracle or MariaDB running in the cloud. And then Aurora came after that to deal with some scaling issues, as well as some licensing issues that those other databases have, and also just to kind of make an AWS branded specific tool to, I guess, pull people in, right?
Yeah, I mean, I think the big deal with Aurora is its storage, underlying storage layer, right? And so Aurora is all about speed and availability. So what you would expect from the commercial RDBMS engines, but with things like MySQL and Postgres. So it's purpose-built storage, underlying storage architecture, which by the way is also used by Dynamo, right? So this is like one of their core gems that they have there at AWS is this Aurora storage technology.
Right. Yeah. So Aurora works today with provisions. It's provisioned. So you say this is the size you want. Maybe it's a micro or a medium or large. And then you pay based on that size and based on the amount of data that you store in it. And the size is like I guess it's per minute or hour that it runs. Do you actually know that off the top of your head, whether it's minutes or hours? It's just how long.
Yeah, I mean, I think you can think Aurora is really no different than the other RDS services, right? It's just, again, it's all about the underlying storage. So you still have to provision these servers. You still have to pick the instance type. It's running MySQL, it's running Postgres, but it's, again, what you're getting is the performance and the availability at a fraction of the cost that you normally would get. So it's really that storage layer.
Right. The reason I was talking about how you pay for it is because that'll come up again when we talk about Aurora Serverless, because you don't really pay by the instance type anymore. And you do pay for how long the things are running. I'm sure on serverless, it's by the minute. So probably the same on regular Aurora. It's probably by the minute. So not rounding up to the hour.
Yeah. Or I mean, in a way, it kind of like doesn't matter, right? Because it's like with Aurora normal, it's always on, right? Right. It's always, you're paying for 24 hours a day, right? For as long as it's running. Sure. So it doesn't matter whether they're really billing you at the second or the minute or the hour. Like the important point here is that you're just paying for it 24/7 for as long as your database exists on the network, right?
Yeah, that's
versus
a great
with
point.
Serverless, totally different story.
Yep. So he kind of then went through, the question, what is a serverless database? I guess that they, inside AWS, they literally ask themselves that, like, if we're all about making things serverless, what does that mean for a database? And some points he talked about where it has to have automated capacity management. So it's got to scale down and scale up on its own without people doing anything. It's got to be so that you only pay for what you use. And you can't worry about things like patch management. You can't worry about things like performance management, like tweaking database parameters. It's got to have built-in availability, so you don't have to make sure that it's running in multiple AZs or, across regions or anything like that. It's just got to do that for you. And then finally, it's got to have the same customer interfaces that you're used to. So putting in a schema or making SQL queries has to be the same as it was for Aurora, or be that Postgres or be that MySQL, syntax. It's got to be the same. It can't introduce a whole new language to talk to it. It's got to be something that you're used to. So those were their tenets when they decided to make Aurora Serverless.
John, I'm curious, did they make any comparisons to Dynamo? Because, I mean, essentially, DynamoDB is NoSQL serverless, and Aurora Serverless is basically the exact same thing, but it's for a relational database instead of a NoSQL database. So I'm just kind of wondering if, as they were talking about what is a serverless database and what it meant, did they compare that to what they've already done with Dynamo?
They didn't compare it to what they've done with Dynamo, and Aurora as a serverless database has a major limitation in terms of how it scales that Dynamo does not have. And I guess we'll get into that in a minute. So when they were looking at how to build this, they thought about different workloads that RDBMS databases typically handle. And they were wanting to make sure that they could do things that are useful for people with really episodic workloads, like dev and test, like it just comes in and goes away, mostly idle, or really spiky workloads like gaming, where you have to provision for the peak usage. So they wanted to make sure they could handle things sort of across the realm of the types of workloads they get, not just the consistent, transactions coming in at a regular rhythm. Because if that's all you have, then maybe it does make sense to just have your provisioned database. You know what you need, right?
Yeah, because I'm sure, I mean, it's absolutely the case that you're paying a premium for having the convenience of serverless, right? Yes. So like, if you don't have the predictability, if you're not using it, 24/7, where it's kind of just sporadically using it, then something like serverless makes a lot of sense. But if you're just kind of like the normal steady workload type thing, then serverless is probably not a great solution for you.
Exactly.
Hey there, this is Rich. Please pardon this quick interruption. We recently passed an internal milestone of 30,000 listens, and I wanted to take a moment to thank you for the support. I was also hoping to encourage you to head on over to iTunes to leave us a review. Positive feedback and constructive criticism are both incredibly important to us. So give us an idea of how we're doing, and we'll promise to keep publishing new episodes every week. Okay, let's dive back in.
So then he got into how it works. And this is where we'll spend the rest of the conversation. And I guess the thing that was most surprising to me is that, and it makes sense, right? It's just vertical scaling. So Aurora Serverless will scale you down to the smallest instance sizes if that's all you need, or scale you up to the largest instance sizes if that's what you need. It does not scale you out whatsoever. And so no horizontal scaling capabilities at all. So they're not adding servers, they're just changing servers. And he talked about basically how customers were already doing this today. And I guess, this is something that Kelsus has never done, but it is a doable thing. If you want to switch out your instance type, you can put a proxy in front of your database and basically get another instance type warm and then switch the database instance underneath. And then the proxy can handle rerouting to the new instance. And basically the new instance is still pointing, like all the data is in some disks, right? So changing instances is just a matter of changing what program is pointing at the data on the disks. The data doesn't have to be moved. It's just that the application that is fetching the data and inserting the data has to be on a bigger, smaller, capability machine. And so that's essentially what this is. They have a proxy layer, and then they have what's called a pool of warm instances. So as they see that you're about to scale, they'll warm up an instance for you, make sure it's ready, and then they will switch it out. So let me tell you a little bit more about exactly how that works. So the proxy layer is a multi-tenant proxy layer. And of course, it's multi-AZ, it's multi-region, it is ready for you. And it's multi-tenant, meaning it's not just you hitting that proxy layer. So then I think that is to sort of protect AWS's own costs. They don't want to waste containers or machines just, on customers that are not really fully throttling that proxy layer. And it is a place where they can keep customer data totally separate and segregated, and it's fine. The different calls through that proxy are not going to be able to see each other. And I guess they also did a lot of testing around making sure that there's no noisy neighbor problems in the proxy. So that's and the proxy, all it is doing is just taking the SQL statements and sending them to the database. And then that warm pool, each instance is for a particular customer and that customer's workload that they're doing. So the pool itself might have lots and lots of instances for lots and lots of customers, but whatever it's warming up for your workloads is going to either be a bigger or a smaller instance based on the direction your work seems to be scaling. Let me find here in my notes. There's some things about the timing of this that were just amazing. Let's see here. So basically what it does is it looks for, there's one third component to this. They have the multi-tenant proxy layer, they have this pool of warm instances, and then they have a monitoring system. So the monitoring system is just looking at your CPU. It's essentially just CPU usage and connection. And as it sees CPU usage starting to climb or connections starting to get up towards max connections, that's when it warms up a new instance. So if you're scaling up, it's going to get one ready. And then I guess they have the ability to read in pages of the database very, very quickly and have that thing ready, have the buffer of the database ready to go. And then they look for a little window of traffic, like lowering, and then it takes 1 second to switch from the old database to the new database. So you do have a 1 second essentially outage in your system as you scale up or scale down between databases. Just amazing, right? Like most applications can handle that, especially if they're web-based applications. One person can wait an extra second. They'll just think their internet connection had a hiccup.
Yeah, pretty cool. I mean, it kind of all makes sense. Like if you had to do this yourself, like you could do this with your own proxy, and then you would play around things like snapshots. Yep. Right, and backups and all that kind of stuff, right? So, and they kind of have the same problem, right? Where that 1 second hiccup, that's basically where they find a spot where like they can basically lock the database, stop the write, stop the transaction, so they can switch the pointer of where they're pointing to from a storage aspect. But they need that, you have to do that pause, right? So that you don't miss any of the operations that come in. So for them, because of the Aurora storage layer, that can be really, really fast versus like if we had to build it ourselves, doing things like RDS snapshots and restores, it's going to take a lot longer.
Right. So one of the things that Aurora Serverless can do is it can scale all the way down to 0. So if you just stop having transactions and it notices, it'll just, if you configure it, if you let it have its default configuration, it'll scale to nothing. You can tell it that you want a provision capacity unit, the minimum to be 1, in which case it'll never scale all the way down to 0. If you do let it scale all the way down to 0, then you can the time to get a database up for you as soon as you start getting traffic is 30 seconds. So if you can't handle a 30-second wait, then you need to keep one capacity unit provisioned at all times. So just around one of the questions was, when would you not use this? When is this not a good idea? And you already brought up, Chris. Well, it's maybe not the greatest idea if you know exactly what you need, because then you can just save money with with your consistent transaction flow, getting the exact size you need. Another reason you might not be able to use it is if you have constantly long running transactions. In that case, they'll just never be able to find that scale point because there's just never that little brief window where they can get in there and stop transaction. And I guess another one, and maybe you could help me understand this because I didn't quite understand what this would mean, but if you use a lot of temporary tables, then they also can't find a time to scale. I guess maybe because those are just in memory. Is that the reason why, Chris? Do you know?
Yeah, I would. I mean, it's sure. I mean, it just has to do with concurrency and locking, and something like a temp table is being built on the fly, right? So there's issues around that, right? And yeah, I mean, I don't actually know whether or not it's back to disk, back to storage. I would imagine it is. Maybe.
It seems like it's a database, even if it's temporary, probably is written.
Yeah.
And then I guess the last reason that you wouldn't use it is if you need to be able to react to scaling in less than 30 to 90 seconds. So if you're real spiky and you start scaling suddenly and you need to react to that, scaling up almost instantly, instead of, okay, it's going to be 30 to 90 seconds before that new warm instance is ready to get switched in, then it's also not a great use case. But, arguably, if you need to react to scaling that quickly, probably you just need to size for a peak, right? Like there's nothing that's going to react that quickly.
Well, I think in that case too, that's going from 0 to something, right?
No.
30 to 90 seconds.
It is. So the switchover happens in 1 second, but the reaction to the scaling does take 30 to 90 seconds. So if it sees transactions climbing, oh my goodness, you're running out of CPU, I'm going to get one ready, and then I'm going to find that 1 second to switch you over. That whole process can take 30 to 90 seconds.
Yeah.
Which is also amazing. It's just incredible.
Well, and that's just like a policy setting, right? Because it's to minimize the thrashing of scaling up and down prematurely, right? So it's kind of just verifying that, there's been enough data here that I'm confident that this scaling decision is going to be the right thing to do.
Right. Which actually is also cool too, because that means maybe you can scale up and down, a few times per 10 minutes, which would be like, wow, that's a lot of moving around instances, but that's cool. Let's see here. So, it's that simple. I talked about the noisy neighbor stuff. Oh, one of the things that was kind of outside the scope of his talk, but came up when he was talking about noisy neighbor stuff, he was talking about how a new thing at AWS is this thing called cellular architecture. Have you heard of them talk about this, Chris?
Yeah, I mean, this is basically just partitioning, right? Like it's just you're breaking things up into its own like cells that can handle it. And I think at the end of the day, you're relying on just partitioning it up.
Right.
So
yeah, and they have a rule where a cell has at most 5,000 instances in it. So that multi-tenant proxy layer, there's going to be lots and lots and lots of those, but each one is going to have no more than 5,000 instances in it, and they're going to be multi-AZ. But that cellular level design gives them better outage protection than even just AZ, multi-AZ deployments.
Yeah, it's all about limiting the blast radius.
Exactly. And so the same goes with the warm pool of instances. There cannot be more than 5,000 instances in that warm pool before they create a new cell. And then at that cellular level is also where they were doing the testing to make sure that there's not noisy neighbor problems. And I guess most of the work that they did with the noisy neighbor problems is just making sure that there's no garbage collection pauses, because apparently the garbage collection is what really hinders other users of the proxy. So it's basically smooth CPU, memory usage. He didn't get into exactly how they accomplished that though. And then, the reason that the instances are not multi-tenant is that they just found that based on reasons of security and based on just not really knowing exactly how much usage the instances were going to get, they couldn't really keep their requirements around noisy neighbors and around security all the way down to the database level. So they just had to give everybody, separate instances of databases, and there was not a way to do multi-tenant databases themselves, which they also don't do in regular Aurora, normal Aurora. Yeah. So I was really excited. I met Anoop later and I told him that we were going to talk about this. And so hopefully he's excited to hear our conversation.
Very cool.
Anything else that you wanted to bring up about, I think we'll probably use this for I'm imagining a couple of our clients that would definitely benefit from this, where we have had issues of trying to scale quickly up our database where we have some spiky traffic. So we'll definitely look at this. What about you, Chris?
I have my own personal blog and I've been meaning to upgrade. I need to go from the latest version. I'm using Ghost, and latest version it only supports MySQL, no longer supports Postgres. So I need to switch to MySQL anyhow. And then, I'm back in it with RDS, which is, it's not, for a personal blog, it's expensive, right? So this is perfect for it. So running Aurora Serverless for my own personal blog would be kind of, and it's a perfect use case because
it is.
I get like 8 hits a week.
Right. And it can handle that. And then if you were to get tech crunched, like, it'd be fine.
Yeah.
You should probably plug your blog. Otherwise you're going to continue getting 8 hits a week.
Excuse me.
Go ahead and plug your blog. What is it?
Upstart.chrishick.com.
Cool.
Now you're going to get more than 8 hits a week, hopefully.
Yeah. We'll see. I guess the other thing I want to point out too is just a little like Aurora Serverless. There's not a lot of magic here. Like you said, it's really just you're just doing vertical scaling, which makes a lot of sense, right? They can't do horizontal scaling because that's one of the issues with the relational data model is like in order to get horizontal scaling, you have to partition, and partitioning relational data is really difficult. So that's why we use NoSQL for really scalable. When we have systems that have to be very, very scalable, like NoSQL is really the only option. And that's why they were built. So something like Aurora Serverless, to be like dealing with vertical scaling, it's totally in line with that philosophy. And, the real magic here just comes in from that Aurora storage layer and the ability to quickly switch, basically from, it's not EBS, right? But it's the equivalent of, detaching from one EBS volume and wiring up to another one, and then flipping the switch and then changing the routing.
Mm-hmm. Actually, you reminded me of something, and this is an open question. I'm not exactly sure, but Anu mentioned that Aurora Serverless doesn't support read replicas, which is a kind of a big deal. So if you have a really, really heavy read system and you've been relying on read replicas to kind of scale out a bit, Aurora Serverless might not be the one you want to choose. It's probably better for transaction processing type workloads.
Yeah, I think at the end of the day, you're probably going to be paying like the same. You're going to be overpaying, right? Because it's not going to make it. It's not really distinguishing between read and write traffic,
exactly
type thing, right? So because again, you're not provisioning anything yourself, so you're not specifying things like read replicas. You have the single endpoint coming in, right? Like just doesn't have that support.
Yeah, it does feel like a bit of a weakness to me, and it feels like a solvable problem where they could notice that most of the traffic is read and they could add read replicas. And I wouldn't be surprised if they do at some. That's just my prediction.
Yeah, there's nothing technically stopping them from doing it. Like, and think they could. Like they have all the metrics, right? They see every transaction coming in. They have the metrics on it. They know what your traffic pattern is, right? They know whether or not it's the right thing to do to be able to have better read
and
performance.
Control of routing because they've got the proxy.
Yeah. So it's a lot of work, but it's definitely it's almost a foregone conclusion if serverless has the traction, right?
Mm-hmm.
And that folks are really using it and adopting it and taking off. Like if they kind of keep pitching it as like, this is really good for like test databases and, for devs to spin things up quickly and spin them down and, infrequent websites type stuff, then like kind of wonder, like, is it even would they devote those kind of resources to it? But you never know.
Yeah, I think they will. And he was, I think, just to kind of clarify, they talked about those workloads because they wanted to be able to be good at those and some other workloads. So I don't know that that's the only types of workloads that they were considering. They just wanted to make sure they understood that that they could handle a variety of workloads.
Right. Yeah.
But hopefully didn't mischaracterize that.
Yeah. No, I think the other way of looking at this too is like something like Aurora Serverless makes a lot of sense when you're first starting out, but once your software, your service has been out there for a while, and you now have some predictability, and then that probably makes sense now to switch from it, right? It's the same. Like this is the same model across a bunch of different things. It's definitely true for like when do you host your stuff in cloud versus go on-prem, right? And so we've seen a lot of companies that will do this. Like they get to an inflection point where it's like, I'm completely overpaying to be running in the cloud. And so you see them pull their stuff out of the cloud and go on-prem. Pretty sure Dropbox did this not too long ago. There's other companies that have done it. And so that's the great thing about the cloud, right? You don't have to have this big upfront capital expense. You don't need to make any predictions. You don't have to know how much you need, right? It's just capacity on demand, but you're paying a premium for it. Yeah. And so the same thing here with Aurora Serverless and any of the serverless technologies, right? You're going to pay a premium for that. Right. And at some point you're going to hit an inflection point where it definitely is like, hey, this is not like I'm overpaying now. This is not the right solution for me.
Right. All right, great. Well, thank you very much for talking with us about that today. And thanks, Rich, for putting this together. We'll talk to you next week.
All right. See you guys.
Later.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/64. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.